Alright, in this video we're going to look at lesson 2.6, and this one's going to focus all about quadratic models. Now let's just review what we've done in the last couple of sections. We've learned about linear functions we know are in the form y equals mx plus b, and recently we learned about exponential functions, remember, on the form a times b to the x power. Well, like I said, in this section we're going to learn about quadratic functions, and quadratic functions when in standard form are in the form y equals ax squared plus bx plus c. Now there's going to be some important aspects to this that you got to understand. Now all of these, anytime we graph any quadratic model, it's always going to be in the shape of a parabola, and that parabola can open upwards or downwards. So here we have two examples, and so in this first example, if we have a parabola that's opening upwards, we have the vertex. The vertex is the lowest point or the highest point, or another way to look at it, the vertex is a point where it changes direction. So if we read a graph from left to right, with this first example, it'd be coming down, and then as we hit that vertex, it's going to go back up again. And in that situation, when it's opening upward, the vertex is the minimum point. It's the lowest point. Where on the right, we see here that here we have a parabola opening downwards. And in that situation, your vertex is now the maximum value. And so sometimes, like I said, a vertex can be either a minimum or a maximum value. Now let's define those more clearly so we can understand what a graph is going to look like without actually having to see it. So anytime we have an equation, the form ax squared plus bx plus c, if a is a positive number bigger than 0, the graph would be opening upwards. So then we'd have a vertex, it's a minimum point. Anytime that a is negative, so if it's a number less than 0, the graph is going to open downwards. And the value of c is always the y-intercept. That is important. Anytime that constant, if we have 2x squared minus 7x plus 3, just by seeing that I can know that my y-intercept would be where y would be 3. And to find the x-intercepts, that's a little bit more trickier. That's where we use the quadratic formula. Now we've all seen the quadratic formula before. This should not be anything new, but sometimes it's really easy to forget why we have the quadratic formula. So again, the purpose of the quadratic formula when going to graph is it gives us the solutions, or it gives us the x coordinates for the x-intercepts. And an easy way to remember this is to put this formula to the tune of Pop Goes the Weasel, which goes something like this. X equals opposite of b plus or minus a square root of b squared minus 4ac all over 2a. So there you go. Sing that in your head a couple of times and you will never forget it. So I want to go back to the beginning. X is equal to the opposite of b. Notice what I said there. I didn't say negative b, I said the opposite of b. So b is already negative. Now b, the opposite of that would be a positive value. So make sure you get that clear. And then also, anytime we square a number, remember it's always going to be positive. So please make sure that you're typing these in your calculator correctly. Or I would just, when you're writing this down, which we'll do an example here in a minute, when you're writing this down, I would just automatically always square whatever b is. Because oftentimes the one mistake that I'll see students do is that if b is a negative value and they write it down, they'll write down like negative 3 squared, but when they type it in their calculator, they'll type it in wrong, and then the calculator doesn't make a mistake, it's all user error, but then the people end up getting the wrong answer. So I would just go ahead and square the value as you're writing it down. Alright, so now let's talk, so that gives us the x-intercepts. The quadratic formula gives you the x-intercepts. Now let's talk about the vertex. So if it's in standard form, to find the vertex, that's going to be a coordinate, remember, an x and a y. To find the x coordinate, we're just going to always take, again, the opposite of b divided by 2a. So it's kind of like the quadratic formula, only just without the square root part. That will always give you the x value for the vertex, opposite of b over 2a. To find the y coordinate, we're just going to take whatever we get for x and plug it in the equation. And when you do that, then that's an easy way to find the y value. So if you haven't already done so, you want to make sure that you get all of this written down in your notes if you're taking notes on your own. Otherwise, if you have my notes printed out, make sure you're just writing down those extra pieces, because this is all very important stuff. Alright, so let's look at this example. So here they give us this equation, 2x squared minus 3x minus 2. And we want to find the x and y intercepts of the graph in part A, and then we're going to tell whether the parabola has a maximum or minimum point and give its coordinates. In other words, in part B, we're finding the vertex. So let's start in part A by finding the x-intercept. So remember, to find the x-intercept, that's where we're going to use the quadratic formula. So to find the quadratic formula, remember, it's going to be x equals the opposite of b. So a is 2, b b is negative 3, c is negative 2 in this problem. I always want to make sure that when it's in standard form, it should go in descending order, starting with your x squared, then an x, and then no values for x at all. So again, our opposite of b, so b right now is a negative 3, so the opposite of b would be positive 3 plus or minus the square root, and this is what I was talking about earlier. We don't want to write down negative 3 squared, because if we type that in our calculator wrong, we'll mess it up. So negative 3 squared, I know would be a positive 9. So we're just going to write down 9 minus 4 times my a value, which is 2, times my c value, which is negative 2. And it's all of that over 2a. That's the other problem that some students make, is they write down the square, they put the just the square root over 2a, but it's that entire piece all over 2a, or 4 if you want to write down 4. All right, so that's the first step. So the next step is we're going to just simplify what's underneath the radical. So we'd have 3 plus or minus the square root of something divided by 4. So when you type that on your calculator, we would have 9 minus 4 times 2 times negative 2. So just do that on your calculator, and when you do that, you should get 25. All right. So at this point, this is where this plus or minus, that plus or minus means that we're going to have two solutions. One where we'd have 3 plus what the square root of 25 is, and one where we'd have 3 minus what the square root of 25 is. So at this point, I like to branch off into two separate routes. So we would have 3 plus the square root of 25, which is 5 divided by 4. And then we'd have 3 minus the square root of 25, which is 5 divided by 4. So this will give us our two answers. So 3 plus 5 is 8, so we'd get 8 divided by 4, which we always want to simplify that to get, in this case, 2. Then we'd have 3 minus 5. Well, 3 minus 5 is negative 2. Divided by 4 reduces to 1/2. So we'd have negative 1/2 would be our other value for x. So our values for x, or x-intercepts, would be at 2 and at negative 1/2. Or we could write it as coordinates and say it would be the coordinate 2, 0, and negative 1/2, 0. All right, so that's our x-intercept. To find our y-intercept, remember our y-intercept is just the c value. So the y-intercept is negative 2, or we would say the coordinate 0, negative 2. Lastly, let's find the vertex. So the vertex, remember, is a coordinate. It's got an x value and it's got a y value. So let's start by finding the x value. So to find the x value, it's the opposite of b over 2a. So again, b in this case is negative 3, so the opposite of that would be a positive 3. And then 2 times a, so 2 times 2 would be 4. So that would give us the x part of our vertex would be 3/4. Or if you want to do 0.75, that'd be fine as well. So to find the y value, we're just going to put our x value into the equation. So just to make it easier, I'll just do decimals. So we'll do 2, whoops. We'd have 2 and then 0.75 squared minus 3 times 0.75 minus 2. And again, this is just something you could just plug in your calculator exactly as you see it. And when you do all that work on your calculator will give you negative 3.125. So that would be the y value. So again, this is going to be a coordinate where x would be 3/4, y would be negative 3.125. Or you could say x is 0.75, y is negative 3.125. But this you have to write as a coordinate because the vertex is always going to be a coordinate. All right. I want you guys to try this next one. This is actually going to be the last example we're going to do. If you have my notes printed out, the rest of the notes we're not going to worry about. So we're actually going to end with this one. So I want you guys to go ahead and try this one on your own. So pause the video, and when ready to check to see if your answer, go ahead and hit play. Let's see how you did here. So for the first part, for the x-intercept, you should have gotten negative 7/3 and 1 as your answer. Or if you would have done negative 7/3 as a decimal, you might have gotten negative 2.3 repeating. But those would be your two x-intercepts. Then your y-intercept, remember, would be the c value, so that would just be 7. Or if you set it as a coordinate, you could have written the coordinate 0, 7. Part B, I forgot in the previous one, but for part B, this is a maximum value. And the way that you can tell that is a is negative, so it would open downwards. And if it's opening downwards, then the vertex is the highest point. So the maximum, or the vertex would be a maximum here. And so to find the x-intercept, remember you do the opposite of b over 2a, which in this case would give you 4 over negative 6, which reduces to negative 2/3, or negative 0.6 repeating, or negative 0.67 even. And then when you plug that in, you should have gotten either an exact answer of 25 over 3, or you might have gotten 8 1/3, or if you said 8.3 repeating. Any of those would be correct. So just recognize that your answer would be in the form of a coordinate with the x and the y value. All right, hopefully you understood all of that. And otherwise, you are finished now with lesson 2.6. So good luck now as you go to class tomorrow with questions that you might have and work on the assignment.